Hello friends, we start with our next topic of two-port network. We have already seen the different type of two-port networks like T network, pi networks, lattice network and bridge network. Now today we will understand how we find these Z parameters, Y parameters and H parameters for all different type of two-port networks. So one by one we will see. First we will go through the T network, then pi and then lattice network. So still, if you have not subscribed and comment and like my channel, please do it, because once you subscribe it will be more easy for you to go through my all previous session. The link of my previous video is already mentioned in my description box. You can go through it and understand the previous sessions. So we start with our first network known as T network. Okay. As in my previous session, we have seen the T network, which is in this form. This is ZA, this is ZB and this is ZC. Since the impedances are connected in the form of T shape, so it is referred as T network. Okay, so now we will see how we will find the Z parameter. As I mentioned that in case of T network, if you will find in case of T network, you can easily find Z parameter. Yes, you can find Y parameter also, you can find H parameter also, but in case of T network, we will simply find the Z parameter. And now we will understand how we find these parameters. So if you talk about the equation for Z parameter, it is given by V1 is equal to Z11 I1 plus Z12 I2 and V2 that is equal to Z21 I1 plus Z22 I2. So these are the two-port equations for Z parameters. Now if I consider this is a two-port network, then this is referred as V1, here is the current I1, this is referred as V2 and here is the current I2. Okay, so now in first condition, if we have to find the Z parameter for Z11 and Z21, as I mentioned in my previous session, we consider that let I2 is equal to 0. Your port 2 current is 0, and once your port 2 current is 0, what will happen? No current will flow here. So for the time being, I will remove this current here from this port. So now there is no current, or you can say the value of I2 is 0. Now I2 is 0, what will happen? This I1 will go here, and since it is open circuit, the entire I1 will flow in this manner. So if you apply one KVL here and one KVL here, you will get V1 is equal to ZA plus of ZC into I1. This is our first equation, and similarly if you apply here, it comes to be V2, it is equal to ZC into I1. This is your second equation. Okay, simply we have make I2 as 0. Since no current is flowing, this I1 will enter into this branch and will move in this fashion. So from here, if you find V1 by I1, so that comes to be ZA plus ZC, or you can say this is your Z11. Similarly, if you find V2 by I1, that comes to be ZC, that comes to be your Z21. So by taking I2 as 0, you have find first two port parameters, that is Z11 and Z21, that comes to be ZA plus ZC and it is ZC. Okay, now we see the other parameters. Now if I1 is 0, now once you make I1 as 0, that means your port 1 is 0, no current will flow here. I will remove it. So here no current. Okay, now this I2 is flowing here, and now this is your I2. So now what happened? This I2 will come here and now it is flowing in this fashion. No current is here. Okay, no current is here. So now if you again apply the loop in the same fashion, then V2 comes to be ZB plus of ZC into I2. That is your first equation, or you can say it is your third equation, first, second, third. And if you apply here, so V1 comes to be ZC into I2, that is your fourth equation. Now if you find V2 by I2, that comes to be ZB plus of ZC, and that is your that is your what? It is Z22. Okay, and if you find V1 by I2, that comes to be ZC, and that is equal to what? Your Z12. So in this fashion you have find Z11, Z21, Z12 and Z22. Now if I write this equation in the form of Z matrix, so Z matrix, Z comes to be, it is in the form of this, that is Z11, Z12, Z21, Z22. So this matrix comes to be in the form as Z11. The value of Z11 comes to be what? It is ZA plus ZC. Z12 we have find ZC. It is ZC and it is ZB plus of ZC. So now this is the Z parameter of T network. So in this fashion we have find the Z parameter of a T network. The important thing is here these matrix the impedances comes to be ZA plus ZC and it is ZB plus ZC. Now if you see Z12 and Z21 are equal. So such type of networks are referred as reciprocal networks. So this T network is basically a reciprocal network. Okay, so this T network is basically a reciprocal network. Why? Because Z12 and Z21 are equal. Both the impedances are equal. Okay, so this is a reciprocal network. Okay, I should write here it as a reciprocal network. Okay, since Z11 and Z21 are not equal, so it is not symmetrical in nature, but yes, the network is reciprocal in nature. Okay, so this is about the Z parameter of a T network. Now we will talk about the pi network. As I mentioned you, pi network is represented in the form of its admittance parameters. So it is YA, YB and YC. YC is the impedances which is in between these two, YA and YB. Just keep in mind this is the standard pi network. Okay, and now again if I consider here as V1 and the current is I1, so this comes to be V2 and current is I2. As I mentioned earlier that in case of pi network we find what? Y parameters. We find what? Y parameters. Yes, you can find any type of parameter, but yes, for this case we will consider only the Y parameter because it is easy to find the Y parameters here. So the Y parameters equations was given by I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus of Y22 V2. So these are the port equations for I1, I2 for Y parameters. Now for finding out the Y parameters, we will consider first let V2 is 0. This is the procedure. Okay, so when you make V2 as 0, once again I will redraw it. This network comes to be in this form. Since this is short circuited, this will be removed. Okay, and now it is in this form, and now this is the current I2, it is flowing in this manner. Okay, and this is I1, this is V1, this is YA and this is YC. Very simple. When you make V2 as 0, that admittance will get short circuited and this is the form. Okay, now under this condition if you have to find the Y parameters, how we will find? See, V is basically I into Z, which Z is known as your impedance. But when you find I, that comes to be V by Z or 1 by Z, you can refer it as Y. So here I is what? It is V into Y. Don't confuse. Okay, so here if we apply KCL, so we can easily find. If you see this is I2 is the current I1, so what is the current here? This current is I1 plus of I2, the current which is flowing here. Now I2 will move here, I1 will move here. Okay, so if you apply law of KCL here, so you can easily find the solution for the two parameters, that is Y11 and Y21. Okay, so now this is your current I2 and V1 is the voltage which is in this branch. So what you can write? You can write here as the value of I2 comes to be, it is V1 into YC with this as our formula. This I2 as V1 into YC. The only thing is whenever we stand on this node, we say that the current is moving in this fashion, but this current is coming towards the node, so that comes to be what? It is minus. So this is your equation first, very important equation. Similarly, when you stand here, if you see, so what is the value of I1 plus of I2? That comes to be V1 into YA. Yes, V1 into YA. Okay. Okay, so now from here you can say that for finding out the parameter Y21, it is I2 by V1, and here it comes to be what? Minus of YC. First we have identified minus of YC. This we put in this equation, so we'll get I1 minus of V1 YC is equal to V1 YA, or you can say I1 is equal to, take V1 as common, YA plus of YC, or from here you can say that I1 by V1, that is Y11, is YA plus of YC. So this you have find as the next parameter. So you have find this one and that one. Okay, Y11 and Y21 we have identified. Okay, so this is first condition. Now in next we will consider that V1 is 0. Okay, and we will see. So this was our port equation. Now V1 will take as 0. So what will happen? Once again we will redraw the circuit. So this will get short circuited. This is the admittance, this is the admittance, and it is in this form. Current here is I1, and this is your V2, and this is I2. What is the current here? Is I1 plus of I2. Okay, and this is your YC, this is your YB. Now once again we'll see that this V2 is the potential here, and as per our previous concept, you can say that the value of what? I1 is equal to minus of V2 into YC. Okay, say this is your equation first, or I1 by V2, that is what? You have taken V1 as 0, so it is Y12 is equal to minus of YC. This is your first second, you call it as third. Similarly you can say that I1 plus of I2, that is what? It is minus of YB into V2. Now you put this value here. So from here you can say that minus of V2 YC plus of I2, that is equal to this is plus, okay, this is plus YB into V2. So from here you can say that I2 is equal to, take V2 as common, it is YB plus of YC, or from here I2 by V2, that is Y22, that comes to be YB plus of YC. So in this fashion we have identified this also. So this is your next parameter. So yes, we have find all the 4 parameters. We'll see here. If I write the Y matrix is given as Y11, Y12, Y21, Y22. So that comes to be Y is equal to, Y11 was YA plus of YC, it is minus of YC, it is minus of YC, and it is YB plus of YC. In various examination you will find, if you remember these parameters, they will directly give you the Y parameters and they will ask what is the Y matrix. Okay, just to save the time, if you remember it, you can easily find it. Only the important thing is, just keep in mind this YA, this is YB, and YC is always keep here. Sometimes a confusion will be arises, you take it as in clockwise direction, so you consider this as YB, YA, this as YB, and this is YC. So this direction is incorrect. Okay, this is only the direction, that is YA, YB, and YC. Okay, just keep in your mind. So this is very important. So this is all about the pi network. Now we go for the lattice network. Next is our lattice network. We have already discussed about the lattice network. This is your lattice network. Very important thing is this is your ZA and this is your ZB. This you keep in your mind. If I consider this as V1, this is V2, so here is the current is I2, here is the current is I1. Okay, and what we find here? Z parameter. What we find here is known as Z parameter. So for understanding this, once again I will redraw this figure in some broader form. In various PSUs, question used to come from this lattice network. Okay, so this is important. Now in lattice network, as I mentioned, you will find the Z parameters. So we'll see how we find the Z parameters. Very important thing, ZA is the series impedance and ZB you can say it is a parallel impedance. Very important thing. ZA is it is series branch impedance. This you keep in your mind, and ZB is your parallel branch impedance. Okay, this is very important. So if you remember the formula, you can directly find out. Now we'll see how we find it. So as the Z parameter equation is given by what? It is V1 Z11 I1 plus Z12 I2, V2 it is Z21 I1 plus Z22 I2. So for finding out Z parameter, first we will consider that I2 is 0. Now in the diagram I will try to explain you, when I2 is 0, no current will flow here. Okay, so forget about this current. Okay, now this I1 is flowing here. Now if you see, if I consider that some current IA is flowing here, so what is the current here? It is I1 minus of IA. Very important. What is the current here? It is I1 minus of IA. So this IA is flowing in this manner. Okay, here this I1 minus IA is coming here. So what is the current here? It is I1 minus of IA. This IA is coming here. When both the current is added, I1 is flowing here. Okay, so just keep in mind, here this current is IA and here this current is I1 minus IA. You have to only understand the directions and divisions of the current just to find out. Now either you can apply this loop or this loop, it's okay. So we apply the easier loop, that is this one, from here to here. So that comes to be V1 is equal to, since same current is flowing, you can say that ZA plus ZB into what? It is IA. Say this is your equation first. This loop I have applied. Okay, this one, this is the path. So in both the path you will see the current is IA. So V1 is equal to ZA plus ZB into IA. Now this figure is your figure of 8. Okay, this figure is your figure of 8 in this fashion. So I am applying one KVL here also. Okay, since this branch is not connected with this branch, it is just over that branch. So if you apply this figure of 8A for KVL, so there is no voltage exists. You can say 0 is equal to, here is ZA plus ZB, the current flowing is what? It is IA, yes, in this fashion. And now I am moving in this fashion, so I am going against the direction of the current, I1 minus IA. Okay, like that. So like that I am moving, and now like that I am moving in this fashion. So this is also against what? It is ZA plus ZB. Yes, should I write? So this is your equation second. Very simple. Now if you rearrange this equation, you'll see I1 ZA plus ZB is equal to 2 of IA ZA plus ZB. So if it is cancelled out, from here you can say that the value of I1 is equal to twice of IA. The value of I1 is equal to twice of IA. So can you find the first parameter? Yes, if you put the value of IA as I1 by 2, you will get the first parameter. So from here, if you see, I should write here please understand, this V1 will become equal to ZA plus ZB into I1 by 2, or you can say V1 by I1, that is Z11 is what? It is ZA plus ZB upon 2, which is your first parameter which we have identified. Very important. Okay. Now for finding out the value of Z21, that is V2 by I1, we have to identify that relation. So if you apply this loop, you can easily get, or if you apply this loop, you can easily get the answer. Okay. Okay. So for easier, we will apply this one. Okay. Or you can apply that one also. There is no issue. So if I take this as our loop, so V2, that is equal to minus of IAZA in this fashion, okay, plus of ZB into I1 minus of IA, yes, or you can say it is ZB I1 minus of IA, you take as common, it is what? ZA plus of ZB. The value of IA is what? I1 by 2. Simply put that value, so that comes to be 2 of ZB minus of ZA minus of ZB whole upon 2 into I1. So from here you can say that V2 by I1 is what? That comes to be ZB minus of ZA upon 2. So this is your Z21. So in this fashion, if you identify Z21 comes to be ZB minus ZA upon 2. This is your next port parameter you have identified. Okay. Now, if you see this in same fashion, you have to find, first we have find from V1, now we will find from V2. So I'm not going to find, just try to understand. If you find the same thing from here, you will get the same solution. So should I write directly? Yes. From here, if you see, the value of your Z22 again comes to be ZA plus ZB upon 2, and value of Z12, that comes to be ZB minus ZA upon 2. It is in the condition when I1 is 0. First we have find for I2 as 0, so we will get these two values. Similarly, when you make I1 as 0, again you will get the same value. Why? Because this network, this lattice network in this position is basically a symmetrical as well as a reciprocal network. Because I mentioned you, if you talk about the Z parameter equation, this is Z11, Z12, Z21, Z22. So if it is equal, then network is symmetrical, and if these two are equal, the network is reciprocal in nature. So for this network, if you see, Z11 and Z22 both are equal, Z21 and Z12 both are equal, and it is ZB minus ZA by 2. Now very important thing is, keep in mind, ZA is your series impedance, ZB is your parallel impedance. Few very important questions were asked from this lattice network in GATE also, in ISRO also, in DRDO also, in JTO also. There are a lot many examinations in which this question was asked. Only the important thing is you must remember the value of Z11 and Z21, and it is ZB minus ZB by 2, and this is the position of ZA and ZB. Okay. Now sometimes they will take it as ZD and ZC, so you must remember how ZC and ZC should be arranged here. Okay. So this is about the lattice network. Now the last is bridge network. So friends, this is your bridge network in which I mentioned you that we find Z parameters. So this is some type of complex networks So see, in various z parameter you must remember the value of z parameter, then only you can easily solve the problems. So in this condition I am not going to solve because the procedure is remains same, only you have to apply some KVL and KCL and then one can get the answer. So in this case I am directly writing the solution for z11 and z11, z22, z12, z21. Okay, since this network is a reciprocal network, because you will see when you find the value of z12 and z21 comes to be same. So here I am directly writing the solution for z11, it comes to be zc plus of za into za plus zb plus zd, and this comes to be zb plus zd. This you have to keep in your mind. Similarly, z22 comes to be zc plus of zb into za plus of zd, and the sum comes to be za, zb and zd. If you talk about z21, that comes to be so this is z11, this is z22 now, and this is z12 and z21. The value is zc plus of product of these two impedances and sum of these three impedances. So this you have to remember. Okay, somehow you must keep in your mind for finding out the solution, because you will find in engineering service examination such type of question used to come, but if you start finding the solution it will take much of time. So you must remember these formulas directly and find the answer. The only thing is you have to just keep in your mind that z11 and in case of z22, these are the arrangement of impedances. Okay, whether the positions are changed, there is no effect once you remember these formulas. Okay, so it is important, and it is only possible when you go through the number of problem solving sessions. So this is about the z parameter for a bridge network. Okay, now we'll see some different class of networks. So this is a special class of two-port network. We call it as gyrator box. This K is referred as gyration resistance. This is V1, this is I1, this is V2, this is I2. This is a symbolic representation. Okay. The very important property, sometimes you will find this question used to come. It is a passive, linear, lossless, non-reciprocal two-port network. Very important. This you remember, because the question used to come, a gyrator box is a passive network, a linear network, a lossless network, or a reciprocal network. So if you remember this, you can identify what is the correct answer. So there exists a relation between the output to input in terms of gyration resistance, and it is given by V1 is equal to minus of Ki2, which is known as first equation, and V2 is equal to Ki1, this is known as second equation. These are the two very important equation in case of gyrator box. This you have to keep in your mind. The relation between input to output and from this V2 to this V1 in terms of gyration resistance is given by V1 in terms of the relation between V1 to I2. It is V1 is equal to minus of Ki2 and V2 it is Ki1. Now how you remember it? Please see, this direction of K is in this form in gyrator box. So if you find the relation between V1 to I2, the direction of I2 is different and the direction of K is different. So that's why this minus used to come. But if you talk about this V2, the direction of this K and the direction of current is in the same direction. That's why it comes to be positive. So this is just for remembering the sign convention. Okay. So now if you know these two equations, can you find the different parameters? Yes, you can find it. How? Please see. If I talk about the Z parameter, so you can say that V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus of Z22 I2. If you rearrange this equation in this form, it comes to be V1 is equal to 0 of I1 minus K of I2, or V2 is equal to K of I1 minus of 0 of I2 or plus of 0 of I2. Yes, so from here, if this is a, if you compare with this equation, the equation for two-port network, can you write directly the Z matrix Z as 0 minus of K, K 0? Yes, so this is a Z matrix for gyrator box. Very important. This matrix is very important because you will find the question used to come. So this is a Z matrix for gyrator box. Okay. Now if I rearrange this equation, please see, for Y parameters. So should I write the equation for Y parameters as y11 v1 plus y12 v2, I2 is equal to y21 v1 plus of y22 v2. Now if I arrange this, should I write, first I arrange this, I1 is equal to 0 v1 plus v2 by k. Yes, and if I write this as I2 is equal to minus v1 by k plus 0 into v2. Yes, this equation I have arranged in this form and this equation I have arranged in this form. Now from this equation, if you write the Y matrix, that comes to be what? It is 0 1 by k and it is minus 1 by k 0. So this is the Y matrix of gyrator box. Very important. Okay. Now if I talk about the transmission parameters T, so equation is given by what? It is V1 is equal to A V2 minus of B I2 and I1 is equal to C V2 minus of D I2. This is your transmission parameter equation. Now if I arrange this again in this form, so this comes to be V1 is equal to 0 V2 minus of K I2, this equation, and if I arrange this, so I1 is equal to V2 by K minus of 0 I2. Yes, should I arrange? Yes. So from here the transmission matrix T is given by 0 minus of K, 1 by K, it is 0. This is your transmission matrix. So this K comes to be positive. Why? Because our B matrix is in the form of what? Minus of V1 by I2, and that's why this comes to be positive. Okay. The value of B is what basically here is K, and that's why I put here as K. So the transmission matrix T is in the form of 0, K, 1 by K and 0. So now you have to find Z, Y and T. Okay. So for gyrator box we have identified all three matrices. Just keep in your mind because this is one important question. Okay. Now as I mentioned that this is a lossless device. Gyrator box is a lossless. What is the meaning of lossless? What is the meaning of lossless? The meaning of lossless, that means if I talk about the power, that is V1 I1 plus V2 I2. So if it is 0, or you can say summation of P is 0, then you can say that there is no loss, or it is a lossless. Okay. So if you see, the value of V1 comes to be what? It is minus of k I1 into I2. If you put value of V2, it is k I2 into I1. So that means P comes to be what? 0. It means there is no loss in the transformation through gyration resistance, and that's why this device is referred as lossless. Okay, the value of P comes to be what? It is 0. Now another important thing in case of gyrator box is, if its output is, if I talk about this output, if this output is replaced by say capacitor C, then its input voltage behaves like an inductive, and if it is removed by an inductor, then its input current behaves like a capacitive. How? We will try to understand. Okay, so in one case I will explain you, another you can do it at your own. If I remove this output terminal by say voltage with this as V2, and this is the current I2, so V2 is what? It is 1 by C integral I2 dt. Since the direction is opposite, so you can say that it is V2 minus 1 by C integral I2 dt. Okay. If you differentiate it, that comes to be dV2 by dt, that is equal to minus of I2 by C. Okay. Now the equation for gyrator box, as I mentioned earlier, that is V1 is equal to minus of KI2 and V2 is equal to K of I1. If we rearrange these equations, basically what we are doing, by terminating output with a capacitor, we are trying to identify the input condition, that is V1 by I1. Okay, so we have to replace this V2 and I2. Now if I replace this V2 and I2, so V2 is in the form of this and I2 is in the form of this. Okay, so from here you can say that the value of V2 is what from this equation? KI1. Okay, first, and what is the value of I2? It is minus of V1 by K. This is second. So these both I should put in this equation. So what it comes? It is K di1 by dt, that is equal to minus of minus get plus V1 by Kc. So from here if you see, V1 is equal to K square C di1 by dt. Now if you analyze this equation, it is in the form of V is equal to L equivalent d square I by dt square. No, not dt square. It is in the form of V is equal to L di by dt. And what is this represent? It represents the voltage across the inductor. So from here we understand that if output is replaced by capacitor C, okay, and if you solve it, you will find that the relation between V1 and I1 is in this form, that is V1 is equal to K square C di1 by dt. So basically this represent your equivalent inductor, L equivalent. Okay, from here you can say that the value of L equivalent is what? It is K square C. Okay, so I have just mentioned you to understand that yes, if output is replaced by C, the input behaves in the form of your inductive representation, and if output is replaced by inductor, input behave in the form of capacitive representation. Okay, so this is all about the gyrator box. Finally we move with the next two-port network, this is your ideal transformer in which the turn ratio is given by N1 ratio N2 and it is 1 ratio N. We will more understand about transformer in our AC analysis, but here you just understand and why we are discussing here about the two-port network, because the specific parameter known as transmission parameter generally asked in ideal transformer case, and we'll understand that how we find it. So we know that the voltage or current relation of transformer, that is V1 upon I2, is given by I2 upon I1, that is equal to N1 ratio N2, or here it is 1 by N. Okay, so this is very important equation of a transformer, and with this equation several numerical problems you can solve here. Okay, so for ideal transformer, generally the T network used to be asked, that is your transmission network, and it is given by A, B, C, D. So you have to find A, B, C, D. The equation for T network is given by V is equal to, V1 is equal to AV2 minus of BI2, and I1 is equal to CV2 minus of DI2. So if you rearrange these equation with the help of this equation, so you can easily get the answer. So if I compare V1 upon V2 as 1 by N and I2 upon I1 as 1 by N, so can I rearrange this equation in this form? Yes, I can arrange. So should I write V1 is equal to V2 by N minus of 0 into I2? Yes, and I should write I1 is equal to 0 V2 minus of N I2. Should I write? This I have made from this equation, this I have made from this equation. Just try to understand. I1 simply I should write it as 0 V2 minus of N I2, and this I can write it as V1 is equal to V2 by N minus of 0 I2. Now if you find the T matrix for this condition, the T matrix comes to be what? It is T, the transmission matrix comes to be 1 by N 0 0 minus of N. Very important. So this is a T matrix for an ideal transformation with turn ratio as N. Okay, so this is very important expression and various question used to be asked. So here it is 1 by N is equal to what? It is N1 by N2. So N2 by N1 is what? N. This you remember, very important. Okay, so this is the condition of ideal transformation. Now in my next video we'll more discuss about the numerical problems of two-port networks. Okay.